Today we're going to be talking about dilations, so make sure that you have a piece of paper and a pencil in front of you and write the title dilations down on the top of that paper. So let's first start off with a review. So I know it's been a minute, but we've covered 3 different types of transformations before today's dilation lesson. Those 3 different types of transformations are translation, which is a slide, so we're moving the object left or right or up and down. A reflection, which is what we think of when we think of a mirror, it's reflecting over an object. And our last one we covered is a rotation, which is when we turn an object. All 3 of these transformations keep the shape congruent, which is really important to remember. All 3 of these keep the shape congruent. Remember that congruent means exactly the same. So we're just moving the object. We're not changing the shape or the size of that object. In today's lesson, dilations, we are transforming the figure, but this time it's going to produce a similar figure. And that similar figure is going to be similar to the original by proportionally shrinking or stretching the figure. That word proportionally is key, which means the figure is similar, not congruent. If we look at these pupils, this is what I think of when I think of dilations. This is an undilated pupil, and this is a dilated pupil. So going back to that word proportionally, when a figure is dilated, it must be proportionally larger or smaller than the original. Proportionally means that it's going to remain the same shape. So if we think about those dilated pupils, we have a circle, which is the pupil, with a certain diameter. So we don't know how big the pupil is, it's just some diameter's length long. If we end up shrinking or decreasing the size of the circle, it's going to decrease the size of the diameter. So if we think about it decreasing, notice the diameter gets smaller and smaller as we decrease it. If we increase, the circle increases the diameter. So if we look at that again, that diameter is increasing. But it doesn't matter if we're increasing or decreasing, it's always going to be a circle, and it's going to have some kind of diameter. We're just changing the size or the scale. So keep in mind, it's the same shape, it's always a circle. It's just a different size of the circle. So just going over some vocabulary now, when we're talking about the original figure, that is going to be called the object, and the new figure is going to be called the image. And remember, the object or the original figure is labeled with your just letters, your variables, A, B, C. So this would be triangle A, B, C. The image or the new figure is going to be labeled with letters followed by that prime symbol, which is just a little apostrophe. So this is triangle A prime, B prime, C prime. We use dilations every day, whether you think about it or not. So these top 2 pictures are showing dilated objects. So this is a enlarged arcade machine. This is an enlarged ruler. These are dilated to be decreased. So we know if we had a map of the entire country that is the same size of the country, that would be a really big map and it would be really hard to look at. So we dilate the United States down so we can fit it into a map so it's easy to see the layout of the states. We also dilate down in architecture, so when we're thinking about building a huge building like this, they create a mock-up or a prototype that shows what this building is going to look like, just a scaled down version of it. And then this last one is a scaled up object, just like the rest of those. Remember, dilations are enlargements or reductions. Think about some things that you would not mind dilating to make larger or smaller. My example is a TV screen. So I would like to dilate my TV screen to be larger so I get a larger image of the whatever movie I'm watching. So think about something that you wouldn't mind dilating. A lot of the answers that I get in class are like bugs. So dilate bugs to be smaller so we don't have to deal with huge spiders. I also get dilating like candy bars and things that you eat that you really enjoy to be larger so you can have more of what you enjoy. So whatever you think of, I'm sure it's perfectly fine. So let's look at some examples here. So this is an example of a type of problem that I would be giving you in class. So for this example, we're going to be finding the coordinates of the dilation image for the given scale factor k. And so we talked about scale factors yesterday. K is our scale factor. So this problem here gives 3 different points. So we know that this is going to be a triangle. And our scale factor is going to be 1/2. So that means that this is going to be a reduction size because we're taking half of the image. So this is the original image and we're going half of that image. All we're going to do to figure out the new coordinates is multiply k to our x and our y. So for this problem here, I'm taking 0 times 1/2, which is going to be 0, -2 times 1/2, which is going to be -1, and so on and so forth. So I'm going to take 1 times 1/2. Half of 1 is 0.5. Half of 3 is 1.5. Half of 4 is 2. Half of 1 is 0.5. And that gives me my answer there. And so that's all you're doing to figure out your answer, is taking all of these numbers and multiplying them each individually by whatever your scale factor is. So you can see that happening here. I have one more example for you, and I want you to do this example on your own. So again, we've got 3 different points, and they're actually the same 3 points as before. The only thing that changed between these 2 problems is instead of the scale factor being 1/2, your scale factor is now 2. So you're going to be multiplying each of these points by k and getting your answer. So go ahead and try that out now, and then double check your answer with mine when you are done. Hopefully these are the answers that you got. So if you notice, all we're doing is multiplying by 2. 0 times 2 is still 0. -2 times 2 is -4. 1 times 2 is 2. 3 times 2 is 6. 4 times 2 is 8. And 1 times 2 is 2. So if you have any questions over how to solve dilations, please just send me an email and ask.